Michael Obiaho. I am the CEO of Finpad Social Enterprises. We are into solar energy generation. Today, I will teach you how you can build your own solar inverter with your battery and your solar panel to generate your own electricity like this one, which can power your home appliances like your television, your fan, and your lighting point. I will show you step by step how you can build your own circuit like this with your IC, transistors, resistors, with your transformer and your MOSFET, all the components that is required to produce solar inverter system. This is our circuit we use to produce our solar inverter. This circuit, we have two pieces of 10k resistor, two pieces of 1k resistor, 22 ohms, 100k resistor, 3.9k resistor, 1 variable resistor, capacitor, 104 capacitor. This one and this one is 10k resistor. This and this 10k resistor. This is 22 ohms resistor. This is 1k. This is 1k. This is variable resistor. This is 100k resistor. This is 3.9k resistor and 104 capacitor. This is variable resistor, 104. The value is 104. Turn it this way. Now connect our 1k resistor together to pin 16 of the IC socket like this. We have soldered 1k resistor together with pin 16 of the socket. We connect another 1k resistor to pin 3 of variable resistor to pin 4 of the IC socket. 1, 2, 3, 4. This line is pin 4. Like this. This is 1k resistor to variable resistor and pin 4 of the.
This aspect of the course will help you understand the basics of electricity, because you need the background knowledge on the concept of electricity and electronics before you go into the theory and practicals of inverter designs, especially for those who are not in the field of science or engineering. You have to take this aspect very, very seriously so that you can review some things in the background aspect or the basic aspect of electricity and what is on. If this material were to be a conductor, for example, copper, silver, gold, steel, stainless steel, or any other conductor material, you know, once you apply a potential difference across the terminals or the ends of this material, what will happen is that the electrons will begin to move because they are mobile. These materials, they have electrons that are mobile, meaning they can move. Now, these electrons begin to move in one direction. As they move in that direction, electric current begins to flow in the opposite direction. That is why conductors always allow current to flow through them. Good. So when this negative charge are deposited in one end of the material. That end of the material is the negative side, and when negative electrons are leaving this side of the material to this side, what do you think will happen to this side? This side will automatically become positive. Yes, so that is how we come about negative and positive. Good. So when we come back to the concept of batteries, the positive side is always the side that current flows out from. So current always flows out from the positive side. Good. And then flows in through the negative side.
We have connected 10k resistor to pin 11 of the IC socket.
By setting resistors, we make use of the color code. The color code is actually used to identify the value of a resistor. Now, in the concept of the color code, there are several requirements. First of all, it's required that we understand the colors present in the resistor, and then secondly, we understand how the colors are shared across the columns of the table. We can see here the chart. So you can see on this chart we have a column for significant figures, we have one for multiples, tolerance, temperature coefficient, and failure rates, and then this is the colors. Now there are 4 different ways a resistor can be coded with colors. The first one is using the 6-band method. The second one is using the 5-band method. The third one is the 4-band method. The fourth one is the 3-band method. The band here is simply the colors. Now, when a resistor has 6 colors or 6 bands, the first four bands will be separated from the last 2. You can see we have 4 bands here in this region, and then we have 2 bands, and we have a gap in between. So the first 4 bands will be separated from the last 2 for a 6-band coding method. Then when it's a 5-band coding method, the first 4 bands will be separated from the last one with a gap. And when it's a 4-band coding method, 3 bands will be separated from the last one with a gap. And then for a 3-band coding method, we have 3 bands. So this is the coding method, and each of these bands have pipe, and water is said to be flowing through that pipe. If you have a pipe and water is flowing through that pipe, how do we describe the speed of the water? We can also describe it using the word current, but this time around, is it going to be electric current? No, of course, but we can call it water current. Now, water current will be what? The rate of flow of water with time. So if you are to calculate water current, you are going to be talking about the volume of water flowing with time. Hope that's clear. So this is just another way for understanding the meaning of current. So current simply talks about how fast something is moving, and since it's electric current, we are talking about how fast is charge moving, charge or charges. How fast are the charges moving? So when we can get the rates at which the charges are moving, then we can know how much current is flowing through a particular material. So when we have so much charge moving, the charges moving is so much big charge. We have big charge or a lot of charges. No, we can't describe that with material, but you have a lot of charges flowing through a material within a short time, short or little time. Now, how do we describe that? We say that material has a high electric current because a lot of charges are flowing through the material within a small amount of time. So the current is actually
This is our complete inverter circuit. Now we are about to test it to see if it is working by connecting it to the transformer. The MOSFET and our battery to see if we can produce light. Let's go. As I said, this is pin 11. We connect it to the gate of the MOSFET like this. Pin 11. Pin 14 to the other side of the gate of the MOSFET this way. We connect drain of the MOSFET to secondary side of the transformer this way. This is the secondary side A. Gate B of the MOSFET to secondary B of the transformer this way. Then negative of the circuit to source negative of the MOSFET like this. Positive of the circuit to center tab this way. Positive of the circuit to center tab of the transformer this way. Then our battery to our battery negative terminal. Connect negative terminal to negative of the inverter circuit this way. Then positive terminal. Okay, let's first of all connect our lighting point. This is our lighting point. Lighting point to the output of the transformer. Output of the transformer this way. Then our light. This is our positive of the battery terminal to our positive of the inverter. Simple inverter system, step by step from beginning to the end, like this. It's working. That is the simple inverter circuit you can construct in your house by yourself.